going to take a look at an example that wants us to solve a radical equation. I've outlined some steps earlier on one of my slides in my presentation. The first thing that we need to do is make sure that we isolate the radical first. Then we will take both sides to an appropriate power to eliminate the radical. Then we will do whatever remaining steps of algebra are necessary to solve for the variable. And then finally we will make sure we test our solutions so that we're not in a case where we have any extraneous solutions, some of the problems that will arise. So here we go. We need to isolate the radical expression first. The radical here is the square root of this quantity 2x minus 3. It's not the only thing on that side of the equation, so therefore it is not isolated. This 3 is currently on the same side of the equation, so I need to get rid of it by subtracting 3 on both sides. And that will leave me with the square root of 2x minus 3 is equal to 5. Now, to get rid of a square root, the inverse of taking a square root is squaring something. It's like the inverse of taking a cubed root would be cubing something. The inverse of a fourth root would be taking it to the fourth power, and so on. So we're going to go ahead to get rid of the square root here. We're going to raise both sides to the second power. On this side, that's not really going to do anything other than cancel out the square root. So we just have 2x minus 3. We don't have to do a whole bunch of multiplication or anything there. Oftentimes I see people try to actually square that binomial underneath. No, the squared is just canceling out the square root. On the right-hand side, 5 squared is 25. And I sometimes see students make a common mistake there of trying to multiply instead of squaring. They say 5 squared is 10. They multiply 2 times 5 instead of 5 times 5 with that. So just be careful there. Here we have a linear equation from Algebra 1. At this point, we can solve this in 2 steps by adding 3 to both sides. If we add 3 to both sides of this equation, we will be left with 2x is equal to 28. And then finally, if we divide by 2, we will get that x is in fact equal to 14. If I wanted to test my answer to see if it made the original equation true, I can go all the way back there and try to plug it in. 2 times 14 right there would be 28. 28 minus 3 would be 25. The square root of 25 would be 5. And 3 plus 5 does in fact equal 8. So this is our solution to this radical equation.